Hello, my name is Yifan Zhu. Today I'm going to be talking about my choosing topic of my BQR project, which is cavitation on aircraft. First of all, I would like to introduce what is cavitation. The cavitation describes the process of formation of vapor phase of a liquid when it is subjected to reduced pressures at constant ambient temperature. Cavitation has become a significant design consideration for devices that handle liquids. The performances of liquids, especially hydraulic liquids, can be strongly influenced by the cavitation. An example of such increasing drag of hydro vehicles, limiting effective thrust, decreasing power output and efficiency of turbines, and dropping the pump heads. The main form for cavitation to harm the equipment is causing corrosion on the surface when the fluid is passing. On the basic level, this phenomenon is almost an inevitable occurrence for operating hydraulic system, which raised my strong interest in of how the cavitation happens in the most aircraft and the way of the aircraft preventing it. From my perspective, it was initial consideration for aircraft since there are so many hydraulic units in the operating system and hydraulics high demands on their safety level. Normally, the most frequent section on airplanes where cavitation occurs were actuators and pumps, since they are main components that utilize the hydraulic fluids. Consequently, a lot of energy was transported through these components and speeding up the process uh, of the hydraulic units get damaged. From this point, the temperature usually gets higher and higher. Therefore, choosing the right place to monitor the performance of fluids on these sections were important to consider reducing the cavitation. Another factor that cause would be the types of fuel and the hydraulic fluids used in the system. It is intuitive to think that different fluids would have different properties and performance under certain temperature and pressures, which can significantly extend the cavitation. So, being aware of the solutions of these problems potentially being on the aircraft become the next stage of my research. There are several methods present to reduce, even prevent the cavitation. One of the methods is patented, an invention of special valve which can reduce noise and corrosion caused by the fluid through a valve. An effective valve can be a very straightforward way to control the fluid performance. Another option is to utilize gear pump with refined design, which slots are cut into the gear teeth to reduce the effects of cavitation. The same consideration methods can be also utilized in the section of pipes, tubes, and hydraulic components with good durability and corrosion resistance. Finally, it is also important to have regular checks of valve joints and anywhere else that might likely to fail at the point as soon as something shows a sign of failure, potentially protecting the system using predictive maintenance. Here is my quick summary of my BQR project. Thank you for listening. Thank you.